Hi everyone, welcome back to Unscripted Coding. Last week, we were playing around with a Caesar shift, just really quickly showing how you can build an encrypting and decrypting tool using Caesar shift. It's very basic, I didn't have a lot of time, and this week is very similar. I have some limitations on what I can do on my computer, so I thought we can go through kind of the same exercise. We'll pick a random algorithm from LeetCode and try to solve it on screen. I'll try and talk it through. I'll be as verbal as I can while trying to think through one of these problems, and hopefully it doesn't stump me too hard. So for those of you unfamiliar with LeetCode, LeetCode has a whole bunch of programming problems for you to solve. So I'm just looking through this. You can merge lists, sort lists, you can solve Sudokus. Basically, they're giving you an algorithmic challenge to solve. And they have all sorts from easy to medium to hard for you to just try out your skills and keep building those problem solving skills. Now, why it's really important is because, of course, the really, really dreaded Google interviews. If you want to get into one of those top tier tech firms, say Google, Amazon, Microsoft, they usually ask one or more of these questions in which you're going to be asked to solve it on the spot, try and explain your way through it. Now, what I'm going to do is try and attempt that. Obviously, I need to preface this by saying, who knows where this will go? I don't think I am. Well, I know I'm by far not a great algorithm person, but we'll see how far I goes, and it'll be really bad if I get stuck along the way. So I'm just going to pick one. Let's not pick one from the first page. Let's go page 5. We'll go one more, page 7. Pick one from here. So one of the things is that LeetCode has solutions for some of the problems, but not all of the problems. So we'll pick one with a solution. So one of these three, and so acceptance, I assume, means a success rate. So I'm going to pick this one right here just because it has the highest success rate. Don't want to embarrass myself in front of the screen. Okay, let's just skip it. So you have a question right here. You're trying to minimize deviation in an array. Now I am going to use Python 3. They want us to return an integer here. So let's just return 3. Okay, let's go through the question here. I will zoom in so you can read along with me. You are given an array nums of n positive integers. So you have an array or a list of positive integers, 1, 2, 3, 4, 5. N is the number of integers. You can perform 2 types of operations on any element of the array any number of times. If the element is even, divided by 2. If the element is even, divided by 2. For example, if the array is 1, 2, 3, 4, then you can do this operation on the last element, and the array will be 1, 2, 3, 2. If the element is odd, you multiply it by 2. For example, if the array is 1, 2, 3, 4, then you can do this operation on the first element, and the array will be 2, 2, 3, 4. The deviation of the array is the maximum difference between any 2 elements in the array. Return the minimum deviation the array can have after performing some number of operations. Okay, so they're trying to have you, so you can go through each element and multiply numbers up, and divide numbers down, so you can bring them closer. That's not true, because you only have the option if the element is either even or odd. You can't just pick and choose what is low and high to bring it closer. You want to make sure that, so let's say you have the array 1, 2, 3, 4. You basically want to find what, you want to pick larger numbers and bring them down. So you're going to go through, and let's say we pick the median number, the average, and just say, there's a better way of doing this, but let's start with that. We'll go with an average number. Anything higher than that, if they are even, then you want to bring it down and divide it by 2. Anything lower than the even and is odd, then you want to multiply it by 2 and try and close the gap where you can. Now the question is, you can perform 2 types of operations on any element of the array any number of times. Okay, so the other problem here is, let's say you have a number 6. The first time it's even, you can divide it by 2. But once you bring it down to 3, you can't multiply it back up. Or, sorry, if it's 6, you can bring it down to 3, but because it's even now, or sorry, it's odd now, it's a 3, the only thing you can do is multiply it back up. So you can only keep dividing or keep going down in that direction until it flips, from even to odd. Okay, return the minimum deviation the array can have after performing some number of operations. So I was stuck here, some number of operations, to know whether they will give you a limit. So find the minimum deviation after 3 operations, 5 operations. So return the minimum deviation the array can have after performing some number of operations. So in example 1, you get 1, 2, 3, 4, and they expect 1 because you can bring it to 1, 2, 3, and 2. Then, and so you see the next one, you go 2, 2, 3, and 2, and then the deviation will be 3 minus 2 equals 1. Okay, the next one, 4, 1, 5, 23. So the first thing you probably want to do is bring this down to 10. Still very high, bring this down to 5. So you'll have 4, 1, 5, 5, 3. And then over here, they say move the 1 up to 2. 4, 2, 2, 5, 4, 2, 5, 5, 3. And then the deviation will be 5 minus 2. Finally, this one will be 2, 10, and 8. So you'll want to bring the 10 down to 5. So it becomes 2, 5, and 8. 2, 5, and 8. 8 can go down to 4. 2 can't be multiplied up, so you'll have 2, 5, and 4, bringing it to 3. I guess, yeah. Okay. So my first inclination is to build a helper function first to say, to determine what the minimum deviation is. And define helper. Current deviation. So you get self. Okay. Less. You return. I guess we'll keep with return 3. So we got a list of numbers. What we're going to do, and these are all positive integers. Trying to think here, we could import math. I don't know if that will allow us to do that. Okay, that is fine. Oh, okay. Let's try and do this on Code Sculptor. Okay. I don't get a debugger here. Okay. I get a console though. No? What happens if I say print 2? Okay, so there's an output, so maybe I should, well, I'll do it in Code Sculptor. What I want to do is math.max nums. Cool. So I wanted to find the max of the list, and obviously you find the max of the list, and you find the min of the list. And Python makes that super easy. You just use the min and max function, and I'm glad it doesn't even need to come from the math import. But we get that, and we go max minus min, and then we will return that. Print. So 1, 2, 3. 3 minus 1 is 2. Perfect. I am not going to call this helper current. I'll just make it too long. Let's just call it current deviation. So next one. What we want is minimum deviation. 1, 2, 3, 4. I think that was their test case, correct? So 1, 2, 3, 4, the expected output would be 1. Okay. So what I'm going to do is let's look at the average. So Python average list. It looks like, okay, all they did was sum over length. So the average value, average equals, you want to total up all of the numbers in nums, and then you want to divide it by the number in nums. And so print average out, we get 2.5. And so what I'm looking at is, where do I want to narrow this down? And I might even want median. All right, Python median of list. Oh, cool. Right. We can sort. We can sort the list. So How did we do that? Sorted. Sorted. So that will be more helpful, I think. And how do I sort it in reverse? Reverse equals true. Okay. Wrong place. Put it over here. And just zoom in a little more. Okay, so we have two really useful pieces of information here. We have the average, and I'm still debating whether it makes the most sense to go with the average. We have the list sorted. And so what I think that will mean is I'm not even sure we need the average. We're just gonna go with the sorted and start from the top. For let's go with for num in S. We'll go through each one. No, that makes no sense. We will take the first one. That is the highest number. And what we want to know is, can we lower that down? So if it's even, we can divide it. If it's not even, then we're stuck. Yeah. So what I'm doing here is, if the first element of sorted is even, then my syntax is right here. If even. Good. Okay, so if the first element is even, then we want to divide it. S0 equals S0 divided by 2. Okay, and hopefully we get 2, 3, 2, 1. Good. And we will just put an integer to it. If it's even and we divide it by 2, we won't have to worry about the rounding. It will always be even. Okay, so 2, 3, 2, 1. And what I feel like the next step is we're going to resort it. But let's go through the bottom then. If the last element, which is a -1 index, modulo 2 equals 1, then we're going to double. So if the last number, and therefore the lowest number, is odd, we can double it, and we should take that opportunity to double it. So we multiply it by 2. Okay. And then what I'm going to do is use the self.current deviation S. Print this out. And we're definitely going to have to loop this, but let's make sure this works first. Okay, so what we've done is taken the highest number, moved it down, take the lowest number and move it up. I think what I'm going to do, instead of doing that really, using that average thing, is there's no limit to the number of times we run this operation. They're not going to penalize us for being highly inefficient. So what I'm going to do is put down current deviation equals we right away say this is our current deviation. This is our current deviation. We're going to lock in the current deviation, record that, and then we're going to keep seeing if we can beat that. We're going to keep trying to beat that, and if it beats it, then it replaces that current deviation, and then if it doesn't, then we revert back to what we had before. We lock in that first initial one, and then we so while, how do I want to do this? I could think about this really poorly and think of a high cap. So I'm thinking, first of all, if I'm being very, very lazy, I can take the highest number and basically divide it by 2. So say the highest number is 40. If we divide it by 2, we get 20, and that's the maximum amount of iterations. That number going all the way down is in theory the highest amount that we'll ever want to go down by. Let's go with that for now. Max iterations equals divided by 2. Zero. While max iterations it's greater than 0. And of course, we have to increment here, I plus plus. Okay, so for each iteration, we sort first. We bring the highest number down, the lowest number up. Then we will put down if the new deviation is less than current deviation, and current deviation, so we'll replace the current deviation with this new number. Else, so if deviation actually got higher, then we are going to, let's just make I, well, I don't need infinite. I equals max iterations plus 1. Then return current deviation. Local variable s. Let's go we can get rid of this. And we don't need the import math. Let's see how this does. I can already think of a couple of issues with this, but I am curious if this will pass. Let's run. And it was accepted. They only did one test case. Okay, so my issue here is that you are reducing and increasing the numbers at the same time. I can't think of an immediate situation, but it may be that you're at a point where you want to decrease the top number, but you want to hold the last number steady. Oh, and there are other issues as well. What if you had two numbers? So let's say there's four numbers and it's 4111, and you want to move both bottom numbers up. Hang on just a second here. So what if you needed to simultaneously move two or three numbers up? We keep targeting that last one and we chain the top one together. Where would that situation would be? Let's say it's 411. We'll keep bringing it down. You know what? Let's just try that out right now. 4111. See what we get as an output. Those will come up to 2, 3 will be 2, it should be 0. So 4 would come down to 2 because it's divided, and each of the ones will come up to a 2. So it would end up as 2, 2, 2, 2, and therefore the deviation should be 0, but we're getting 1. Okay, how do I... Okay. I think what we're going to do is for each loop, we only do one. We don't multiply and divide at the same time. We should only do one operation at a time. That will deal with that whole simultaneous issue. How we're going to decide is actually, since we can just keep calculating the current deviation, we should. So S sorted, okay, we'll have S min and S max. Okay, I am just gonna make duplicates. Okay, so if the top number is 0, that... Okay, my new kind of branching thought is, if the top number is odd, let's say 9, will the second number matter? And I realize now it doesn't. We're always looking at the top number anyways. So once the top number can no longer come down, that is as far as it can go. So if the top number is 0, we're gonna adjust S max to S max equals 0. And if S, we're gonna adjust S min to the same one. Okay. Now we're going to what I want to do is compare the deviation between each of those samples. One for S, one for S min, one for S max. S is just leaving it plain. S min is where we have adjusted the minimum number up, and S max is where we have adjusted the max number down. Now, what I need to remember is Python case. Okay, I don't think that was a case switch for Python. So what I'm going to do is do a chain of, what I'm going to do is deviation for S equals deviation for S max equals this. Deviation for S min equals this. Max, min, we get the deviation for each one. We want to find and I guess in that case, we won't need this. So I'll comment it out. We're calculating it at every round. We'll look at the iterations afterwards, but we're going to compare. If max of ds max and max and ds min equals s Okay, so here, if the original deviation is better than both of these, then we should break out of the while loop. If ds max if ds max is the biggest, then we should apply ds max to it. So nums cool. Zero. So we've applied it to s max. Okay. Nums is now equal s max. Then if not, then nums equals s min, and then we increase the iteration by 1. Okay, let me walk through what's happening here. We're going to go through a number of iterations. We're going to sort the list. And we do this 3 times. Very inefficient. We're going to apply a doubling or a halving to the s max. So we're going to bring the max number down by half in just this s max array. And then for the s min array, we're going to bring the minimum number up. We're going to calculate the deviations for each of those 3. And then we're going to do a comparison. If nothing has happened, the standard unchanged array has the lowest deviation. Say min here. If it has the lowest deviation, then we just break out and return what the current deviation is. Let's call it best. Or let's call it minimum deviation. That way it's nice and clear. We break out, it gives us the minimum deviation. If the minimum is where we brought the max down, then we replace the nums list to s max, and then we go through this whole sort and whatever again. Same here. If the best deviation is from the minimum, raising the minimum, then we're going to replace nums with that minimum array that we did. Now what we have to do here is just adjust the minimum deviation. This. Make sure we capture that information as we go. And let's try this again. Minimum deviation of 4111 should be 0. Oh, bad input. Okay. I think it is elif in Python. Let's run this again. 0. Perfect. All right. The next question, the next thing I want to do to really polish this up is how we do this deviation. How we do this iteration process. Right now, I've kind of set a absolute maximum of half the amount of the maximum number. So if it's like 4,000, in theory, we can keep having it to 2,000, 1,000. Wait a minute. If we keep having it each time, it is the square root, not just having it. So if I have 8, oh boy, gosh, my math is absolutely terrible. If I keep having it, 8 should be 3. So 2 to the power of 3 is 8. How do I get 3 from 8 and 2? It is 2 root 8. What is 2 root 8? I am completely drawing a blank here. What is the operation to find the 3? This is really bad. Estimating a root, estimating the nth root. Okay. So basically, I'd want to find out what that number is. Is there a smarter way to do this than to just find that number? And I'm trying to think here. Yeah, the best way would be to root it, but you know what? I'm okay with this. There is a better way to find the max iteration, something to do with root. I'm drawing a complete blank. I apologize, but I don't think this is a horrible way to go about it, because we would break out of it far sooner than we would hit this limit. And this limit will never be too low. It will always be too high. It'll never be too low. So we'll run the right amount of iterations regardless. So I am not too fussed about that. Let's see if this will work. You know what? Let's run a couple more tests. I think the expectation was 3. 3, very good. Let's go 2, 10, and 8. 2, 10, and 8. 3. Good. This is the latest version. Let's run this again. And we are good. And let's see what happens when we submit. I think they run more tests, a big battery of tests, to see if it works. Not just the test cases they gave, but... Uh-oh. Oh, no. The expected output is 1 here. Let's see what's happening. We give an answer of 4. Let's just rearrange this first so that I can think about this manually. 86621, 86621. 8 will be brought down to 4. You know what? Let's just print what our final nums. So this is the scenario I was worried about. What happens if we needed to do 2 simultaneously? We needed to do both the first and the second. Simultaneously. And theoretically, the first, second, third, fifth, 10th billionth number all simultaneously to move down together. And I think as I'm thinking this now, the only time this will come up is if those numbers are identical. Because let's say it was 12 and 10, and we should bring both of them up. As soon as you drop 12, 10 will take that position and they will switch back and forth. And this is all mirrored on the negative side. They have to be the same number every single time. And so I think we can write something very quickly here to catch that. Basically saying if S0, the largest number is even, we should be applying that to all of the numbers. We should be applying it to every number in that array that matches that original one. So let's say 6. We should find 6 and replace in the array. Find in array and replace. Okay, you know what? Let's just do it the old school way. I thought there would have been a simple way to do this. But for num in S max, so for each element in the array of S max, let's print num first. 86621. Okay. Let's go length. Instead of going through each element, I want to go through the elements. So in this case, 0, 1, 2, 3, 4, 5 numbers, very good. If S max num equals 0, all right, so we go through each element. If the current element is equal to the largest number in that original array, we replace it with that halving number. And then we can do the exact same thing for the negative. And we go smin, 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 and we are multiplying instead, but of course we should be doing -1. And let's see what happens. 3, 3, 2, 2, 2, 1. That is the expected solution. Very good. All right. Let's throw this back into the LeetCode. See how we do. Submit. Now it's running through and judging, and fingers crossed that works. I think we should have dealt with all the issues at this point. Oh man. So we passed 71 of 76 test cases. look at this one. Oh. This one is a beast. Okay, they were expecting 98,000. So the first two numbers are different. The last two numbers are different. Divided by 2, we get 997. So if I divide the very last number by 2, hang on, let's go back. If I divide the very last number by 2. Okay, I think they're catching us in that very last option. Okay. I love it. I love what they're trying to do. These test cases are they want to get all the edge cases. So I think what it is you have to simultaneously, and this is what we did at the start, simultaneously move the last number and the first number closer. You have to adjust both of them at the same time, or else if you move this one up, it won't be better than before, and if you move this one down, it won't be better than before. You have to move both simultaneously. So we're gonna do this as both. Okay. And I am doing this kind of hacky. This isn't the best way to do this, but this has taken an enormous amount of time so far. I don't know if very many people will be watching through all 53 minutes so far. Oops. Both will be for. So in this case, every time we see the high number, we move it down in S max, but we do it for S both as well. In S min, we move up, and for S both, we move up as well. We are calculating the deviation for both. And I think we can just add a last else if to it. Oh, we're gonna need an S both to all of these. Both minimum deviation S both. Prints or nums. Okay, I think this should do it. So we will move all the way back. Our previous answer was, how many digits is that? 99,599,000. Uh-oh. Am I wrong? Is that not the issue? Okay, let's go back to our drawing board here. If I go 99,803,803,000 and double it times 2, it will be larger than 199,607,607,000. So if I move the bottom number up, it will be larger than the lowest number. Oh no, you gotta be kidding me. Is it possible that we have to do the two lowest numbers simultaneously and the top two numbers simultaneously? Okay. Print. In both. What is the issue here? Okay, you know what? I want to submit and see if this actually dealt with any more of the 76, the 5 remaining test cases. It seems like we failed something even simpler. Wait, we failed? I think I must be implementing it wrong. Okay. Let's do this one. 2228. Let's comment this one out. 2228. Let's get rid of this. Three, 4, 4, 5, 5. So we want to move the 3 up. This one confusing me. That's confusing me. So, the max number, if it's even, can be divided. So we would not want to move these down, but this one we would want to move up. Now, in the last round, why did we not? Okay. Let's remove these ones. Let's see what happens here. Expected 3. Okay. Now. Oh, still not dealing with this issue. I am absolutely stumped here. Let's go back to our So we're still at 71 out of 76 test cases. So I think I'm gonna call it quits. We've clocked in an hour and 5 minutes now. And I guess where I'm at is I'm just stumped as to what the next step should be. Let me hit this one more time. S, S max, DS min, DS both. Do we ever get 98 million? 98,683,000. Yeah, all of these are larger, and so I think we're approaching. So I think this was a really cool one to tackle. I think where the final issue is we have to make a number of simultaneous swaps. And I kind of cheated with just moving the first and the last together, but I can totally see a possible situation, and we may very well be looking at it right here in the face, where we have to move the first three and the last two. And so I think the approach itself here might be wrong. We've been going about this shifting one at a time, one at a time, one at a time. Whereas if we went back to that original approach where we tried to identify some sort of median or average in which everything above we should move down, everything below move up, then that may fix that whole simultaneous issue. But I am going to call it quits. I have to throw in the towel here. I think we did good work. We thought through this all the way through, but we did think a few times about what if we needed to move multiple numbers simultaneously. And the worst part about this one is the numbers are so big that it is not immediately obvious to me. It feels to me like we have to move several of them simultaneously, several of them up top simultaneously, and I'm not going to be able to intuitively see this with such large numbers. So this one was difficult. But going back to it, LeetCode, look at how many problems there are. There are just years and years of fun here for you to practice, for you to get really good at thinking through these problems. And so I hope you had fun just watching me go through this process. I am slightly embarrassed that I didn't actually solve it. I think we solved it for many test cases, but not all of them. So yeah, bit disappointed, but hopefully you found that helpful. Hopefully you thought that was fun as well. So thanks for watching. If you enjoyed this video, please do leave a comment, do like, subscribe, thumbs up, whatever it is, to keep me going on these. Thanks for watching. See you guys next time.